So this is how that data would get stored in the real physical storage. So I mentioned to you a concept called column families earlier, but I didn't go into details. So when you look at the actual storage of the data, so it stores in terms of column families. So whatever the data that comes under one column family would be stored in a single in a sequential, I mean in a set of regions which are sequential. So we have a column family for the basic info, and then whatever the key values or keys that comes under the basic info would be stored in this notation in the disk. And then when you store this data, it would be stored first. I mean, the data would be stored in a sorted order. So the first sorted ordering would be happen based on the raw key, and then based on the column qualifier, based on the qualifier of the column, in this case the name, and then the third would be based on the timestamp. So when sorting based on the timestamp, it would be descending. So whatever the latest one would be, that's the entry on the top. So the advantage of this storage format and then this sorting would be the access patterns. So for example, if you want to get an operation where you want to get, let's say, the email addresses of all the people, or you want to get whatever the information in the basic info field for all the people or a set of people, then all this data would be stored consecutively. And then if you want to take only a partial region of this data, then the data is sorted. So it's very easy to query. And then the access would be much faster because you'd be accessing sequential data, which are in the physical system. So another concept which HBase has is, so this physical storage can grow up to gigabyte or terabytes in terms of the size. So in that case, HBase divides this physical table into things called regions. And then there's, so for example, there can be a region up to BBB, and then another region from there onwards, and then several more regions. And then these regions would be stored distributedly across the cluster. So, yeah. So let's have a look at the HBase architecture. So you have the client, and then you have HBase master nodes, which takes care of assigning regions and taking care of the region servers up and running. And then you have the region servers, which takes care of a set of regions. So this region, so if you look at this region server, it would be responsible for managing and storing region A, for example. And then this region is actually stored across multiple nodes for performance as well as fault tolerance, reliability perspectives. And then this region server would be responsible for that. But in case if the traffic gets high for this region and there's going to be a lot of activity in this region, then the HBase master node will notice that this is becoming a bottleneck, and then it will automatically partition this region A into two regions and store in two nodes across the cluster, so which will improve the performance automatically. Yep. So if you look at use cases, Facebook uses HBase to install the information about the URLs you share, and then the Twitter uses HBase to install the messages, and the Mozilla uses it to store the crash reports. So if you go to the HBase website, there's a huge list of companies and use cases where they called Powered By, where they show the use cases of HBase and how they're using HBase. Yep. So let's move into programming with HBase. So HBase has different APIs. So HBase has HBase shell, where you can log into the shell and manipulate the tables, create tables, delete tables, put data, get data. And then it has a Java API as well as other APIs like a Thrift API and then a REST API. So the other thing is HBase has a MapReduce API where it makes it very easy to do MapReduce computations on top of the data that I stored in HBase. And then you can write these MapReduce computations even using Hadoop-based languages like Pig or Hive. When you're using HBase with Hadoop MapReduce, HBase provides several utility classes for you to use. So for example, the table input format is a Hadoop input format, which takes care of inputting the HBase data, the data stored in HBase as key value records to map task, as well as takes care of splitting the data to create map task. So in this case, if you're using table input format, whatever the data is stored in a single region would belong to a single map task. And then it also provides a mapper and reducer base classes to use and some utility classes which will aid you in configuring your MapReduce computation, and then several writable types. So the writable types are the data types in Hadoop MapReduce computations. So HBase provides a set of writable types which you can use to interact with data stored in HBase. So this is an example of a MapReduce computation with that we're going to do on top of data stored in HBase. So this is a driver program where we configure the job and then submits it. Since we are running out of time, I'm not really going to go into details, but you can get your configuration. I mean, HBase provides a method, and then you can define a scan where you will define the input data for your MapReduce computation, and then you can use the utility methods, right, like init table mapper or the init table reducer to specify which table to use, and then which mapper class to use, and what is the input format and what is the output format. And you can do the same things using the table reducer, init table reducer job to configure the reducer part of your computation. And then when you're writing a mapper with HBase, you can use this table mapper base class to implement your mapper. And then since you when you in the earlier slide we use the table input format. So when you use that, you automatically get the data in the HBase as these two HBase built-in data types. So your key would be immutable bytes writable, and then the value would be result. So in the reducer, you will get the normal Hadoop intermediate data transfer and the normal data types, whatever you output from the mapper. And then the important part is HBase API support storing this data back into HBase tables using these data types. And since when we configure the MapReduce computation using that earlier utility methods, it automatically sets the output format as the table output format. So whatever the data you output here using this put data type would be stored in the table you configured in your driver program.